Hello, good morning, good afternoon, good evening, good night from wherever you're watching. My name is Leander. I'm a developer advocate with Qualcomm, and this is a build along AI on Qualcomm Dragonwing with Edge Impulse. I am super excited about today, and I hope you are too. I would like to introduce David Tischler with Edge Impulse. Drum roll, please. Oh, you even have an Edge Impulse sign in the back. I got it.
Yes, you know what, Rain? It's taped up there. I'm a little bit concerned that we're actually going to witness it fall off of there like halfway through the stream. But before that, can I ask a very silly question? In my view here, all I see for you is a green screen.
Oh, no. Oh, yeah, definitely. We need to not just have a green screen.
Because
That's
all I
awesome.
see is a green screen. And now it could just be me. It could be user error.
No, totally user error.
Yourself, then great, but I don't actually see you. There you are. All right. So your introduction was a talking green screen. But that's what happens when we do things live. This is
welcome to Qualcomm Streaming Live. Glad to be entertaining. It is a Thursday, December 4th. I'll show myself out. It's cool.
Are you actually in a castle right now?
I live in a castle.
You live in a castle? That's fantastic.
No, I'm kind of proud of this place. This is officially my first stream from the new house. I've actually lived here for 4 months, but it's a huge Airbnb looking. Like, I have a chandelier.
You have a chandelier? Well, that's what I was kind of noticing before we went live, and that's why I was asking, like, if you're in some sort of a castle or a dungeon. Oh, no, I guess you have a window. You're not in the dungeon is below. I got it.
Exactly. Well, this is California. We're right next to the ocean. There aren't actually basements. It's like the Alamo.
No, there's none here either.
No.
I'm in Phoenix, and we don't have basements. No such thing here.
No.
Well, thank you, Rain, for the introduction and the fun opening. I'm David Tischler. I'm a developer advocate at Edge Impulse. And for those who are not aware, I know we have, Rain, you and I have discussed and been on other streams and things out in the world in public. But for anyone that's not aware, Edge Impulse was acquired by Qualcomm earlier this year, maybe 6, 7, 8 months ago now. I'm not sure exactly how long it's been. But so, we've been still continuing to, I guess you could say, exist as Edge Impulse, but within the Qualcomm family of solutions. Obviously, Arduino was another recent acquisition as well. And so today, I thought I would take a couple of hours, maybe 5, 6 hours. I've got about 400 slides. And how many did you put together, Rain? I think your deck I was looking at earlier was like 273 slides or something.
Well, I wanted to go very deep dive, and so I expanded it out to about 1,200.
So that's a lot of slides. We'll be done by tomorrow then, no problem.
It's a 2-day workfall. It'll be fine.
2 days.
All night. Let's go.
We were challenged actually to see if we could be done in 10 minutes. I can't do that. I can't do that. But I will quickly today show you how to build an AI model and run it on a Qualcomm Dragonwing-powered device. I'm going to use the Thundercomm Rubik Pi, which is a cool dev board that is based on a Qualcomm Dragonwing 6490 SoC.
Originally in the RB3 Gen 2, this is very stripped down. This
is more dev friendly versus like an enterprise evaluation kit. These are currently going for $99 on Arrow, Codico. I try to think who else has them in stock. There's a few other suppliers as well. Atlantic if you're over in Europe, has them. So you can go and search around. But yeah, these are great boards for, like I say, deving on. So I have one of those on my desk already hooked up and plugged in. And yeah, joking aside, see what I did there? I don't actually have any slides. We're just going to build along.
We're just going to code. I love it.
Yeah, we're just
joking is this is going to be 1 hour max.
No, yeah, we'll
joking aside. We will. Do you have any code or a link to code? Or are we like just gonna live zoom through everything? I love it.
We're gonna go live, zoom through everything. I won't go. I mean, it won't take that long, quite honestly. But if I move along too fast, by all means, certainly drop your questions into chat.
Absolutely.
I'm not able to see chat while I'm on the stream, but Rain, I know you can grab.
Yeah, I got you.
Grab and just interrupt. And I'm also, it's streaming to YouTube, so it'll be available afterwards anyway. So even if I do go a little too quickly, you can always go back, rewind, and just watch again. It's not a big deal. So,
and we're taking questions on both YouTube and if you're watching on our Discord channel, we have a way to get those questions over here. We already have a comment. $100 is like having a powerful Raspberry Pi. That was the
that's actually true. And and you know what? I'll speak to that quickly before diving in, because it's a good point. A Raspberry Pi, absolutely wonderful device. I have tons of them. I use them all the time. In this particular case, the 6490 that is on here has a built-in NPU. So it has neural acceleration. And so it will speed up. I'm going to do computer vision today. Obviously, Edge Impulse supports audio and sensor workloads as well, but I'll do computer vision. It's the easiest to wrap your head around. And so it'll dramatically speed up inference time. All still within a low power envelope. A Raspberry Pi you can use. It'll certainly work fine with Edge Impulse. It does not natively have AI acceleration. It can run on the CPU cores, but there's a significant speed up when running on an NPU-enabled device. And so Raspberry Pi does have those AI accelerator cards that you can put into the PCIe lane,
cool.
But that adds cost. So $100 is pretty reasonable and affordable for something that includes native AI acceleration.
Amazing.
Amazing. Good call out there on that one. So what I thought I would do, Rain, I think I remember from a previous stream, I wasn't presenting on this previous one that I have in mind, but I think I remember you mentioning that I had a burb. Do you remember this burb?
I remember.
You remember him?
Yes.
It was Shreya that was presenting along with Derek. And Derek was the host on that one. But I used my little burb friend here just to build along while they were actually speaking. So I'm going to reuse him again today. And I've got some other parts are laying around as well. This Raspberry Pi, we're talking about raspberries. This Rubik Pi is turned on. I see it's not doing too much because the fan is not spinning, but it is up and running. There's a blinking LED over on this side. So this thing is live, and we'll hop onto it in a moment. But first, let's come back to my smiling face and bring in, if you don't mind, my screen share, please.
Don't mind at all. There you go.
All right, there we are. So to get started, I'll real quickly just cover what is Edge Impulse. It's a web-based platform for building customized AI models. and I very specifically emphasize customized, because there are tons of off-the-shelf models available. Qualcomm has an AI hub full of ready-made AI models. And if you want to do computer vision that identifies and detects humans, cats, dogs, bananas, those things exist, right? Those models, there's plenty of them out there. Just run something off the shelf. YOLO, whatever. Take your pick. But if you have a need to very specifically identify some unique object, and again, I'm only talking computer vision, sensor, accelerometer, humidity, temperature, electric current, any kind of sensor is also totally valid. And audio classification, wake word, keyword spotting, also totally valid, but we'll talk computer vision. If you need to identify this exact object, YOLO does not have this.
Oh, we can't handle it?
Object. It's not going to say, well, that is such and such type of a such and such type of a pepper or salt shaker, whatever.
Oh, wow.
Let's just say this valve.
What?
You produce these. It's the water pump cooler valve. If you are a manufacturer and you produce these, and this is coming down your assembly line rapidly, and you need to do defect detection or inspection of those in some way, YOLO is not, or any of the existing models, I shouldn't say YOLO, there's lots of ready to run. RoboFlow has them as well. Lots of ready to run models. AI Hub is full of them, right? So, if you're building these things and you have a very particular object that you want to not only identify, but then, maybe post-process for defect detection and other use cases, that's when you want to build a custom AI model. And so that's what Edge Impulse is for, customized models.
Very specific.
So I'm going to build a model that will identify our bird friend here today.
Will it identify it as the salt shaker bird friend or bird?
It essentially is based upon labeling, and I'll go through that also. It really comes out as whatever we input as the label, train the model, and once we deploy it, we'll come away with a running model on our Rubik Pi, on the Dragonwing device, that can run inference locally with no cloud connectivity needed. So we'll get through all of those steps in just a moment. I'll give a quick example while I have the screen share up, though. Visual anomaly detection. I'm not going to cover this in detail today. That's a topic for another live stream further down the road, Rain. So there's a 2026 one right there. But as I was saying, if you build this, you are the manufacturer and these are coming down your assembly line, you want to make sure for quality control that they're not scratched, right? Or if you build concrete blocks that are used in construction, or bricks like in the wall behind you. I did actually buy a few bricks and cinder blocks, but they're really heavy, and I'm not that strong, so I use these little small ones instead.
I saw that.
So
that's amazing.
So I use these when doing testing. It's much easier, I find, to introduce defects and cracks and things into the.
Are one of those actually flawed on purpose?
I do have a few that are flawed. Yes. Let's find one. Here's a flawed one. You can kind of see some marking on it. It's a little tough to see.
You.
Yeah.
So that we can see it. Oh man.
Yeah.
Won't solo you.
But yeah, I do have a few that are in fact flawed.
There we go.
But
that's that's so cool.
Some markings on it, and then this one has some. Wait, I'm backwards. This one has some pitting. So we'll cover that in another stream. But that's the reason for then wanting to have these very specific models, because then you can start to do anomaly detection and lay these heat maps over defects. So these are like cracked concrete blocks here that are in this project. But another way to go about it is I was discussing these valves, right? So this is a data set full of valves that are labeled as no anomaly. But after doing a little bit of classification on some, this one here is coming out with some red on it because there's an extended part on here that shouldn't have been there. And I can see so cool. And this one has a rubber gasket at the bottom, but this one is missing the rubber gasket and it's getting overlaid as an anomaly score. The 2.54 and whatnot is, like standard deviation, like how far away from the norm they are. But anyway, so we'll do that in another one. I just wanted to give that context of why it matters so much to have some kind of unique model created.
Now
that we have that,
Hexify specifically said this type of customization is exactly our use case. Already doing anomaly detection with sound, but we'll need vision for our various detection, for our Varroa detection project for keeping our bees safe and pest free. That's amazing.
That's amazing. Yeah. Audio classification. Well, I guess that's a topic for yet another stream. Rain, our 2026 is 2026 is filling up quickly.
Sounds good.
But yes, absolutely. You can do anomaly detection. You can do all kinds of audio classification projects. We just won't touch on it today. And if those devices are in the hive, I would question if there is hardline power to them. You might even want to be down in the microcontroller world, which also Edge Impulse also works with just fine. I'm on a Linux device today. This Dragonwing 6490 will throttle down to about 3 or 4 watts. I don't know. And that's when it's unloaded. I don't know what type of solar would be needed to keep the thing running round the clock plus battery. That's a whole other. But as far as the model is concerned, that's totally doable. That's amazing. All right. So let's get going. Let's try to build a classification, object detection project to identify our bird. Hopefully, again, we're doing this live, so we'll see what happens.
Anything could happen. Exactly.
Anything could happen. We're gonna try though, and we'll have some fun along the way.
Including a green screen.
We did start with a green screen. That's how we began our day. All right, so I am logged in now to Edge Impulse. Accounts are free for developers. There are enterprise options, of course, for deploying models at scale. Certainly, if anyone is ready to go that route, I can connect you through to our sales teams. But just for getting started and developing, the free account is absolutely fine. I'm going to click on create a new project. I'll even just make it a personal one, and I'll keep it on private for now, only because I don't know if this is going to be successful. If it is successful, I can toggle this later to public, which essentially exposes it for anyone to copy and work with. But your data set is made public when you do this. So, you want to be careful if there's anything that is sensitive before you do it. I don't think anything about my bird is too sensitive, but I'm going to leave it private just because I don't actually know. Got to give it a name. And click create new project. Okay. So I now have a project. I'm brought to my dashboard. The very first thing I need in order to build an AI model is I need data, because that's what goes into the model. out is going to come inference, but I need pictures of my bird in order to train the model.
Yep.
Our computer vision model does not at the moment know anything about what we want to identify. So I need to take some pictures of my bird friend here. And I can do that by connecting from the Rubik Pi, which has a webcam connected to it, or I can just simply use my phone to take pictures, which is what I'll do today because it's easy and quick. But you can collect data directly from the device, directly from the Rubik Pi. I'll click collect data, and I'm grabbing, I guess you can't see me at the moment, but I'm grabbing my phone and I'm going to scan this QR. Well, you don't need to necessarily see me take a picture of my screen, right? But I'm going to grab this QR code.
Cool.
And open it on the phone. And there we go.
Oh, nice.
The phone is connected.
Oh.
Now I'm going to collect images. So I'll just click that and give access to the camera.
Nice. Are you on an iPhone?
I'm on an iPhone, but it also works on Android just fine. Cool. And so now I have me. I can't quite get the angle correct, but if I put my bird, there he is. So yeah, so now there's another thing on here that I need to point out. This could also be done in the app, but let's see here. Let's come over to data acquisition. Okay, yeah, we're already on data acquisition. The ability to set the label, which is what we spoke about earlier, is here within the device. It is currently just set as unknown. I'm going to click and I'm going to type in, let's call him.
Oh, it's a male gender.
Yeah, I think based on his markings, I don't know. I think it's a him. I could be wrong.
It's a very bright bird.
I'm going to set the label. Okay, he's now been labeled again.
Okay, what did you label him?
I labeled him as Burb.
Burb. Oh, yes. Excellent. Excellent. I'm glad we're on the same page.
Yes. Okay. Now, I have Burb on the desk.
Go ahead. Yep.
And I'm going to click. He's on the desk. I'm going to click capture.
Okay.
Again, all this could have been done from the Rubik, but hey, there he is.
Oh my gosh. And it automatically
flows right in. Are you building an object detection project? Yes.
That's tight.
I am. All right. I'm only going to grab, quite honestly, about maybe 15-ish pictures. I really am not building a high quality, robust data set. If I
this is not industrial, this is a sample.
This is a sample, right? If I was indeed going to build something that was going to be deployed truly in a factory, in the environment, somewhere out in the world, I need lots of data. I need high quality data. I need data that varies. If you notice here, I'm only taking pictures on my desk. I should really have a variety of backgrounds. Oh, I hear
I was gonna ask you that. Like, what did it matter? What was
it sure
underneath?
Does.
Yeah.
It definitely does. I should have different lighting conditions. I should have different angles. I haven't actually taken. There's the front. I need different cameras themselves because the distance to the object, the angle to the object, the lens, all of this matters.
Yeah.
If I want,
Revolution.
if I want a high quality, generalized data set, I need to do more than what I am doing with my phone at the moment.
Yeah, fair.
But for demonstration purposes, in a build along, this is what we're doing.
Yeah.
All right, what am I at? 20. Let's get one or two more. Okay, so those streamed in directly. They were ingested into the platform. I now have 20 images in my data set. Again, as we discussed, this is not enough. This is not a high quality data set, but it should be enough to prove our point. You know what? It might not be enough to prove our point today. We're going to find out as we continue on. We're going to find out. And so now I have in my labeling queue here 20 items. I clicked 20 pictures, or I took 20 pictures. So I have 20 items to label. At this point, we have images, but we don't know where in the image
the actual verb is.
Mm-hmm. So we're going to set the label around the verb. And I'm going to scroll down. I should have had a slightly larger window, but save the label. It does take some effort to label these, admittedly. There are tools in place to automate this step. There are, so again, I'm only going to do 20 here. This won't take too terribly long. Yeah. But there are AI labeling tools that are in the platform that can tear through this quickly. There are methods to render multiple images. The bounding box that I'm placing around also follows along, helps make it quick. But yes, data set curation is critical in an AI project.
Exactly.
Yeah. Garbage in, garbage out. So data is the input. If we don't get this right, it's not going to build a reliable, accurate, generalizable model.
Yeah.
Again, I'm going pretty quick here, glancing at these, but time and energy and human input.
Oh my gosh, yes.
Can't be understated here. As far as this one's a little blurry. I don't know if it's a blurry one, but yeah, you do need to, in practice, in the real world, give considerable thought to your data set. How many do we have? We should be just about done. This is going to throw our model off, quite honestly. This is because we don't have more of those types of pictures at that angle. The model is it's going to struggle with that, but we'll see what happens.
I also noticed we only took pictures of the bird facing, well, this way on my screen.
Yes, I did this. Yep, go ahead.
If we face the bird this way to actually do the screening, whether or not it identifies it correctly is going to be can it extrapolate automatically?
I'm not entirely sure, and we're going to find out after this model is built. I did that intentionally. You caught me.
Yeah.
Because I was going to mention it at the end when I gave it a try. And I was thinking that it would actually fail, but it might, because there's only 20 images in the data set. I am kind of wondering if, look, the other side of him is also it's symmetric. It's pretty symmetric. I'm wondering if this model is gonna be okay with it. In a real product, in a real environment or situation, I would have collected data from that side as well.
Yep. Exactly. Yeah.
Okay, so I now have clicked on Create Impulse, and Impulse is my machine learning pipeline. I'm I see on the screen, I now clicked on target device and a large drop-down list has appeared, but I see it's not coming through. When you click a drop-down menu, the stream doesn't render the selections here, but I'm going to scroll down and choose.
Is there a Rubik Pi, or do you choose 6490?
Pi 3 is in the list. The RB3 Gen 2 is also in the list, but the Rubik Pi 3 is available directly in it, and we know that it has 8 gigs of RAM. Latency, you can try to stay within certain thresholds if needed. I'm not going to worry about it here. I'm just going to save it, or I should say select it. So now, in order to build our pipeline, we need to choose a processing block and a learning block. The project already knows that we're dealing with images, so it filled in the first one for us. 96 by 96 input for the Rubik Pi is actually a bit low. I can bump this up. Let's do 320 by 320 because we have the processing power available. We have onboard acceleration. We have 8 gigs of RAM. I'm going to create a larger model. If you're dealing with a smaller, more constrained device or a microcontroller, 96 by 96 is the way to go. I'm going to give us a little bit larger model just because I have the power available.
And David, is that based on pixels?
That's pixels, yes, sorry. 320 by 320 pixels, I don't know what resolution.
It's printer level resolution.
So because it really doesn't need, the model doesn't need, so the iPhone probably took, I don't know, 3000 by 3000-ish pixel
huge
resolution. But the features, it's overkill. We would make a model that would be too large if we tried to do that. And our latency would increase and we would lose that real-time processing, even with the power of the Rubik Pi. Now, if we move up to something more industrial,
like an IQ9,
an IQ9, an IQX, hate to say it, but hey, the NVIDIA world. If you're using those kinds of devices, you can bump up beyond this. I'm just choosing 320 by 320 based on it's a medium sized. It's still a little small dev kit. It's It's not the power of the bigger stuff. So, all right. Over on the processing block, I'm going to choose image. There's a whole list of different things. There was a question earlier about audio extraction or audio classification. We're not dealing in an audio world for this project, but the types of blocks that are available vary across, like I said, sensor, audio, or image. But we're in computer vision today, so it's an image project. Our learning block, I'm going to do object detection. Again, the list is much more broad. Transfer learning on keywords, anomaly detection. We kind of talked about visual anomaly detection. There's other stuff available, but I'm going to do, what did I say? Object detection. And the output feature, there's just one label in our data set, which is our burb. So we'll save the impulse. Okay. Next step is the feature extraction. You can choose in the vision world. It's basically RGB or grayscale. In the audio projects, there's a couple more parameters that can be tuned here, but I'll leave RGB, save it, and we'll click. Oh, it'll automatically go. We'll go to generate features. This is going to take a minute to run. So this is where we will talk about the weather, or any.
What's it doing here?
What it's doing is going through the data set, which is quite small.
20 pictures.
Case.
Yeah.
And looking for commonalities and what features are important, what features make up the image itself. We'll see. Okay, job completed. Well, in a larger data set. Where was that larger data set one? I closed the tab. It was on the docs page. Let me see. Oh, here we go. It starts to cluster. What it's doing is looking for, among the data set, what are commonalities? How does the data cluster? If you see like these, quite honestly, this is a difficult data set because even though it is highly clustered, the anomaly and no anomaly are
right
overlapping.
Yeah.
You can kind of see that the no anomaly, the darker green, is more concentrated down in here, and the anomaly, the lighter green, is more concentrated in here. But it basically gives us a visual indication of the way in which the data, like the importance of the features and the way in which those are separating out. And let's see. Yeah, ours is just essentially all over them. Yeah, that's not surprising just based on the small number. But that's basically done. So we'll go to our actual training. Again, this is going to take a few minutes perhaps, so we might just have some weather to talk about. But first, let's just do 50 cycles, 50 epochs. It's probably not enough, but we'll try. I'll train it on GPU, save us a couple of seconds. We'll leave data augmentation alone. Oh, actually, you know what? Let me change to a different model. I'll change to MobileNet.
And what is the significant difference between what you were using?
Yeah. You know what? Let me kick this off and then come back to that.
Yeah.
GPU. Drop that a bit and I'll come and then explain these. And we want int 8 as well. Save and train. Okay. All right. How are we doing on time? 19 minutes left. All right, we're good. We're getting there because we're at the
totally
point,
fine.
We're at the point of training, so we're getting there. All right. Next up is deployment. We're going to either find out if it was a success or a failure. I'm about 50-50 right now. We should take some odds. Right? If anybody's put your bet in. Anybody want to put place your bets in the comments of whether it's going to work or it's not going to work, whether it's going to be a failure or not. But okay, now while it's training, while the training is going, let's discuss the drum roll effect. That's incredible that you had that ready to go. Nice job on that, Ray.
You're welcome.
Okay, so the backbone, the architecture that I chose in this case, I had a choice between FOMO, YOLO Pro, or MobileNet V2. FOMO is a backbone and an architecture that is going to return at the end inference that is, let me think about how to explain it. Inference results based on centroids.
What are centroids?
And what that means is I chose MobileNet V2, and our hope at the end of this is that a box is going to be drawn around our burb. That's our goal, and MobileNet supports that. FOMO is a lightweight architecture that instead of doing the mathematical calculation of the bounding box, the XYZ of the bounding box on the image, instead, it just simply looks at the image and places a centroid, a single dot, on where in the image the object is located.
Yeah.
And it doesn't sound that difficult to do that mathematically in, on a device, but it makes a difference down at the lowest level, the MCU devices. The microcontrollers don't have the processing power to run computer vision, object detection, bounding box location to mathematically come away with this is where it is located in the image. Microcontrollers just don't have the power. So Centroid is a lightweight algorithm of just, we know it's a burb, it's right there, just Centroid. So that's where it matters. It's also a lot, that makes it a lot quicker as well. So, but in this case, I want to see a bounding box.
And it's finished at 100%.
Finished. It did finish.
100%, is that 100% finished training or 100% accuracy?
It is, well, it's actually
or
neither.
Something else.
it's something different, but I'll tell you. So the job completed, you are correct. Okay. It is done training. And when we received our precision score, yes, a nice generic way of calling it is the accuracy, but it's the accuracy across my validation set size. And my validation set was 10% of my images. 2. It only checked 2 images.
Okay.
Again,
and not totally, the image facing front.
I guess not. I guess that one wasn't one of them, or it actually worked. But so it was across my validation set, which was not comprised of very many images. In fact, at only 2 images, if it had failed on one of them, my accuracy there would have been 50%. That would have been pretty bad. So
fair point.
So that is the, oh no, you know what? I'm only going to get float 32 here on this, on MobileNet V2. That's fine. I should have chosen YOLO Pro actually, which would have given me bounding box plus the ability to do int 8, which is what I really wanted, but we'll go with it. All right. So
that'll be our third.
Our model is now built. I'm going to go to deployment. This model has been created. I'm going to type in Rubik, and it's actually just any Linux AArch64 with QNN. And I am going to click build. Go ahead.
Oh, cool. Okay, so we've got a lot of flavors of Linux, especially on our devices. We've got Debian, Ubuntu, Qualcomm Linux. Actually, a friend of mine just reached out and asked if they could get help on Minnows, which is basically a flat pack, teeny tiny for IoT.
Interesting.
What flavor, does it care what flavor of Linux, or?
It doesn't. That will matter when we get to the device, which is going to be in just a second. That's when it's going to matter. But the model itself, just the model file, the .eim file that we're producing, or TF-Lite. In fact, once this completes, I'll go back to the dashboard and I'll show you. We can grab this in a few other formats as well. The model file does not, it doesn't care. It will impact how you run the model file on your device in just a moment. All right, job completed, successful, and my model downloaded, but it downloaded on my laptop, which is not really where I want it. So we'll go grab it from the Rubik in a second. But if I come back to the dashboard, I can actually scroll down and I can grab just the TensorFlow Lite, float or int. There's my int. No, I'm not going to do that. Other projects, you can also grab ONNX as well, depending on where you're going to take the model and run it and what your runtime looks like.
Exactly.
Let's do this. We are going to now really need to say a prayer to the demo gods. I am going to attempt through the power of a USB capture card. So, oh my goodness, what is that? Heartbeat? What was that?
That's
So,
ridiculous. Oh, your camera
sound
switched
effects.
to, there it goes.
Yeah, you know what though? Okay. So my Rubik is running, my burb is ready, my USB camera is hooked up to the Rubik. I'm going to need to start the runner. I could SSH to this device,
Right.
but I'm going to instead do it right from the device. So I have this HDMI port here fed into my laptop. This is where things are going to get at best. USB capture. We have something. Yes, my Rubik Pi is running Ubuntu. You were mentioning earlier the Rubik Pi. You can run Debian. You can run Android. You can run Qualcomm Linux, which is based on Yocto. You can run Ubuntu. I went with Ubuntu just because I'm the most familiar with it. And I'm going to log in. So I have a keyboard, mouse hooked up to
directly to the device.
Directly to the Rubik Pi. I am on the Rubik Pi now. I actually can't believe this HDMI capture thingy is working. I am going to log in. Maybe. I'm not so sure that I know my password. Let's.
I love that.
Hey, it's a live build along. There's no. Oh, okay. It took it. That's a good sign.
That is a good sign.
Let's get a authenticator. Which one is this?
Yeah, remember your screen sharing.
Oh, that's all right. Well, this cycles every 60 seconds. This is fine.
Okay.
This is okay.
Okay.
All right. It did connect. So I'm on the Rubik Pi. It's logged in and it's asking me what project from my list of projects. I'm going to grab our burb. And next up is the microphone. I actually don't need a mic for this project. It detected my webcam. That's good. What name do I want to give it? We'll call it Rubik. And I've just realized I've made a critical mistake.
Oh, no.
What I actually just did was connect the board into data collection mode.
Oh, no.
Which is fine.
Okay.
It's fine. Yeah. You know what I'll actually... The way in which I showed earlier that my cell phone was collecting data.
Exactly.
I mentioned that I could collect data, take pictures of the burb from the Rubik Pi. Well, this is actually how you would do it. That would have allowed me to take more pictures and supplement my data set with more burbs.
Yeah.
What I want to do actually, though, is launch the runner because I want to run the model.
Right. And I saw you just did a Control-C to stop that.
Yeah. Control-C just killed the data collection. If I would have had my other screen on, we would have seen in the studio, similar to the way in which when I was taking pictures on the phone, they were like streaming into the platform. That's what would have happened with that previous command. That's all it would have done, is just streamed in pictures as I could take pictures of our burb. Okay, it's going through the build locally on the device now. This is all automatic, of course.
Yeah.
And I'm going to get my webcam.
I have a question for you.
Go ahead. Yeah, go ahead.
And I'm kind of answering it, but you might be able to more eloquently speak to this. Jeremy Sinclair was asking about
Synclinator.
I know. What about Windows? And I'm explaining that the devices don't actually run Windows or Mac, but different variations of the Debian Linux. Do we have a plan ever to run Windows or Mac OS on a device? I think it would be too big, wouldn't it?
It's in the plans.
Yeah.
It does. I don't know that it works yet. I haven't tried it.
Right. Ooh,
but
that's the device.
Yeah, this is the feed. Which way did we take the pictures? This way? No,
Yeah.
it's the other way.
Oh, we took them that way.
Yeah.
And then if you turn the beak to the right,
if we're gonna get him. Wait,
I know.
Did I see something? Go back. No, we're not getting him. We have failed in our mission today. We have failed in our mission.
It's trying so hard.
It's trying. It's trying. Come on, give me a bounding box. No, we're not going to get it. We're not getting our bounding box today.
And
Where else did I
this
take
is
in?
live.
Well, this is what happens when you build live. What I was hoping for, and I guess 20 pictures was not enough. Just wasn't enough. But what I was hoping for would be that our burb would be identified.
Yeah.
Shame. What if I do
poor little buddy? Oh, yeah, spin it. And also
what if we try?
It's okay, buddy.
But now, and this is, well, this failure is fine in that these are the talking points about the data set that I mentioned earlier. Our data set is not large enough. We didn't train enough. We didn't take enough pictures. I wanted to do it within an hour and I cut some corners and that's what happens.
Now, it's a video right now. We trained it with photos. That shouldn't matter too much, but it might matter a little bit.
No, the GStreamer, it's basically in the background, converting them to individual frames.
Yeah.
It's converting them to frames to JPEGs and processing them on the fly. So it's not looking at raw video frames. It's dumping them to JPEG and inferencing and then dropping the JPEG into the, like, it's creating images out of the feed. All right. Well, that is unfortunate, but
let me ask you this. Yeah. How would we fix this?
So the way to fix this is here. Let me bring myself back and let me bring back.
Oh, the other. Yes.
How real time can the inference be on this hardware? I could have achieved on this hardware. I could have gotten this down to about 3 milliseconds. I actually did not end up using the NPU on this one, on this deployment.
It switched to GPU, didn't it?
Yeah, I took a shortcut around in order to, again, sake of time. But what I really needed was int 8 because that's what loads onto the hexagon. But I was hoping that the float 32 would give me a bit more accuracy. Let's bring back, Rain, if you don't mind, my screen share that has the project. I think, yeah, there we go. So the way to fix this is actually very simple.
Okay.
And I have 2 minutes to explain it. I'm good. Okay. The solution for this is we need more data. We don't have enough data. We didn't train enough pictures for our model to accurately determine what a burb was. Yeah. It's as simple as that.
Yeah.
We need more photos.
Yeah.
More photos, more bounding boxes. That's the solution here. We probably could have trained more cycles. Also, I only
Okay.
trained 50 epochs. That
Okay.
would have helped, but it's just as simple as 20 items isn't enough. It's just not.
Yeah. Okay.
So,
Sounds
that's
like we have a
the
part 2 coming in
yeah,
2026.
yeah. Um, everything here, yeah, I would do more cycles as well, but
Yeah.
it's just a very simple oops, data acquisition is what I wanted. This just isn't enough pictures.
Okay. That's fair.
We need more burbs.
More burbs.
Yeah. So that's unfortunate, but
Yeah.
that's what happens when we build live.
So if you would like to see, I'm going to ask you to put your cam back on your
Back
face.
on me,
for us-
yes.
for
Where?
us to-
Yep. Where am I? This camera?
Yeah.
I am. Okay, and we'll
I'm gonna
come
do
back and wrap
this
it up.
and this. Yeah. I personally, I'm okay with the failure. We
Yeah.
will come back next year and do this again and find our burb. Damn it.
The thing is I knew if we had more time, I would have taken more pictures. I knew 20 was going to be risky, but I rolled the dice.
It's okay.
And I had a feeling it was going to fail, but I should have taken 40 to 50. I've done it on 40 to 50.
Yeah.
I didn't want to draw 50 bounding boxes while live.
Oh no, totally.
So, I mean, it did go quick. It did, but that was our downfall.
Yeah. We've got a question on YouTube. How can I know if a device can run the model well?
The model,
that's a great question.
Size. In the, let's see if this one has it. Yeah. On device performance, we do profile the model at the end, knowing the capabilities of the device. In this case, I had chosen Rubik Pi 3. I can do a quick look here and see it's going to be 11 megs, so it's not going to run on MCUs, arena size greater than 6 megs. There are detailed runs or detailed investigations that you can do by running the Eon tuner, which will go through and I can experiment with, I did 320 by 320 input resolution. I could drop that a bit. I can choose different hardware targets. So you can start to play around and manipulate and understand your device's capabilities.
So the answer is it depends, and you need to experiment a bit.
Yeah, it takes a bit.
Your data, your model, your device, so many factors. Okay.
Yep.
So it's really a matter of playing.
Yeah, and there's some tools built in to help, with the understanding. It is a bit of trial and error. It is a bit of experimentation, but there is science behind it, and tools are built in to help guide that.
Yeah. I gotta say the Edge Impulse, the UI is chef's kiss for
it's simple. I by training am not an ML engineer. I mean, we have ML engineers on the team. I'm not one of them, right? So, but coming from an embedded and IoT background is what I've come from. Yeah. I'm now able, as an IoT practitioner, to add machine learning to my projects, to my, applications. I wouldn't have known how to do that if I would have had to go through, classical training or tooling or Colab, notebooks. I don't know how to do that. I know how to build IoT devices, but I don't know how to, I'm not an ML engineer. But this gives me the ability to add AI to my projects.
Yeah. It's true. Prince Patel, demigods were not with us today, but that's fine.
That's all right.
They will be
not
with us
today.
in the future.
Yeah.
I'm going to wrap this up. David, thank you so much for joining me today. This has been a build along, playing with AI on Qualcomm Dragonwing with Edge Impulse. If you have any questions, edgeimpulse.io. .com. I have it here. Notes on the other side.
And as I think about this, we were also on Discord, right? We streamed over on Discord. So the recording will go on to YouTube for folks to watch. Okay, cool. But the Discord community, I'm in that. I'm in the channels and whatnot. So I'm going to train this. I'm going to take more pictures of my burb, and I'm going to train it, and I'm going to post proof of my burb getting identified.
You can also post that on the YouTube comments.
Yeah, you can do it in the comments as well. We did while you were talking.
Whatever you want to do, we will make it happen. Yes, and.
So there's already more data in here. I've already begun. I'm labeling as we speak. Truly.
Amazing.
Yeah.
Amazing. Thank you so much for joining us today. I'm Leander. This is David Tischler with Edge Impulse. I'm with Qualcomm. And have a great rest of your week into the weekend. And we will see you in the new year.
Yeah.
Thanks, everybody.
Good. Thanks, Rain.
Thank you.